So last week we ended off kind of here where the we talked about the joint size estimation. So maybe just a little bit of recap. So yeah, so maybe we, it will okay, in general we talked about the how rules can be transformed from one to another. So these are the equivalent rules, and in general, what we want to do is we want to push the projection and the selection down towards the query, towards the entire so-called algebraic tree, so that as we go up, when we carry out the joins, it will be less expensive to do so. And that's the general rule that is the general rule. And of course, these are the attributes that are there. I will from now until the exams, I will try to give you more examples to practice to try these rules out as well. Okay, so these are the rules. So we go up to only 8. So from 1 to 8, they are really quite, I wouldn't say important, but useful in a way, useful in the sense of by you use a lot of these from 1 to 8. 9 to 12 are not so much, because 1 to 8 is the typical operations that SQL uses. So 80% of them will be from 1 to 8. 9, 10, 11, 12, yeah, it's a union and joins. So maybe not as so-called practical. Excuse me. And we talked about how we can use transformations over here. And subsequently, we look into the join order. In the join order, it means that depending on the join order, the amount of intermediate, so-called intermediate results, the size of it is going to be a little bit different. And so ultimately, we want to ensure that the intermediate results are as small as possible, so that the resources used will be less. And then we talked about how we can enumerate all equivalent expressions, which, as I mentioned last week, this is in fact a very expensive operation. So it is actually a big O of 3 to the power of n. I think last week when I mentioned this, even if we were to use dynamic programming to find out the so-called intermediate, so-called to avoid recalculating the intermediate steps, it will still take a cost of this, which is still quite an expensive step. So in this slide actually says that if there are shared expressions that we are able to calculate, so this can be done one time and shared across these two scenarios. So for example, if there are multiple enumerations of the same tree, we are able to use shared sub-expressions to reduce calculating them again. But still, it's going to take a lot of time. Yeah, so it's not a cheap operation. Okay. Next, we want to estimate the cost of operation depends on the size and the statistics to the input. So these are some of the heuristics. Oh yeah, so why do we use this is because to enumerate all is very expensive. So we really want to avoid enumerating all, and so we use heuristics in order to not enumerate all. So these are some of the heuristics that we can use. So first will be, for example, the size of expression join, the join sizes of expression. So this will be what we will be looking at later on in the lecture slides. We may also use past results in order to find out how quick or how to say how quick past queries were being done, and so we can sort of speed up various access, various retrievals, various data retrievals. So these all will be statistics to find out how fast or how slow a certain query, or rather a certain joint expression form will take for a query to be executed. Okay. So right now we will focus more on the first one. Okay. To estimate, given the expression, estimate the cost based on the catalog. Okay. So these are some of the base numbers that we will use. N, which is the number of tuples. Okay. BR, the number of blocks containing the tuples of the relation. So we have seen some of these already. Okay. L, the size of a tuple in a relation R. Okay. F, which is the number of tuples in a relation R that fits into a block. Okay, so let's say if let's say there are n tuples, so I want to know in one block, this number of tuples here will be f, and they will have br number of blocks. So n will be approximately equals to fr multiplied by br. Okay. The number of tuples in the block multiplied by the number of blocks. Okay. So if the size of a block is, let's say, is capital L, the fr would then be equals to L divided by L. If let's say size of the block is capital L. So yeah, so this is how the symbols are related. Okay, VR is the number of distinct values that appear in the relation R for attribute A. So it's the same size as projection. So what does this mean is that let's say if it's, let's say ID and let's say what's a good measure, let's say department. So this is the people that belong to certain department. Let's do so in this case, VAR of ID on faculty table is going to be equals to 5, because there are 5 distinct values over here, and VAR of department in faculty is going to be equals to 3, because 1, 2, 3 distinct values over here. Yeah, so this is how we look at VR. And this is the same size as that of a projection, mainly because if I project out a department, it's going to give me CS, physics, and chem. Hence, it's the same size. And of course, naturally, the other things will flow as well. So if this is the number of blocks, and this is the number of files that can fit into a block, so NR will be equals to B divided by F. So it is similar to, why do I have this? Let me see. F is number of tuples that fit into a block. Wait. Correct. Yeah, sorry. What am I thinking? Yeah, so yeah. So yeah, I don't know why. Today I'm little bit distracted. Not distracted, just blur. I don't know what happened to me today. When I was driving, I keep driving, taking the wrong turn many times today. Yeah, so yeah, so these two are the same. Yeah, so yeah, they're the same. Okay. Yeah, so this is just equivalent to the other one. So the statistics about indices, everything. Yeah, so statistics are like the height of the B tree, number of lead pages, and everything else. Okay. let's go to the next slide. Okay. So how do we estimate the size of a selection operation? The size of a selection operation is, let's say if I have an equivalent relation, and we are going to estimate that this is a uniform distribution. This is the estimated number of tuples. So if let's say this is ID, right? Yes, CS physics chem. So if let's say sigma ID equals to 1. So what is my VR? My V of ID faculty is equals to 5. My size, which is n of R, is equals to 5 because there are 5 rows here. So my 1 divided by V IDFR will be equals to 1 divided by 5. And so my size is equals to 5 times 1 divided by 5, which is equals to 1. Okay. Okay. So so it means that this is like the expected value of tuples that is going to be removed returned by that expected number of tuples that's going to be returned. So if let's say I have sigma of department equals to CS, what's going to happen is n is going to be equals to 5. My V of department is 3. So it will be equals to 5 times 1 divided by 3, which is 5 over 3. Okay. Similarly, if my department equals to chemistry, what is the estimated size? It is still going to be the same, 5 divided by 3. It doesn't really matter what my this is. It just matters on this because I'm using the VR on based on my attribute value. Any questions? All clear on this? If I'm going too fast, let me know. Okay, I think everybody is clear. Repeat again. This is covered in the exam. We haven't come to the part where it's not covered yet. So this is covered in the exam. Okay. Okay. Then the next one is the range operator. So if I select and A is less than a certain value. So what this means is that once again, this is the range. Okay, so if it's A less than greater than a certain value, so what I want to do is I want to see this is my minimum, this is my maximum, and this is my V. So I just want to get the proportion of this over this. So this numerator gives me A, the denominator gives me B. And this is the expected, this ratio gives me the number of expected, I won't say number of values, but it is more like the range of values between the minimum to B, and B gives me the full range of values from maximum to minimum of A. I multiply it by N, and it's going to give me the expected number of values that I'm going to see over here. Okay, if I have this, how would this formula be changed to? This formula will be changed to NR times maximum minus V over maximum minus minimum. Because if I have this, it means that I want to calculate this value. Okay. Okay. So if I want to look at A greater than or equals to V, I want to calculate this value. And so it will be maximum minus my V divided by maximum minus my minimum. Let me know if there is any point that I can clarify on this slide. Okay, I'll go on to the next slide. Okay, in this slide, it is the conjunction. So is this condition and so it's multiple n conditions. And what we want to do is we want to assume that, so this is the assumption that the conditions are like how to say like independent from one another. And so what is going to happen is that, so I have theta 1. We assume that the size of this is S1, its size. And the size of theta 2 is S2. Okay. And so what we do now is that we have a probability of the, okay, if we have the size there, the probability of theta 1 being selected is going to be S1 divided by n. And the probability of theta 2 being selected is equals to S2 divided by n. And so on. And if we assume that all these conditions are independent, it means that we are able to multiply all these conditions together. And so we will end up with the, or rather what we are calculating over here is the probability of all the conditions occurring. Okay? So that is the, so if we, so it's n. So that is the probability of all of these conditions occurring. And so the probability of all these conditions occurring is going to be the multiplication of all. So this gives me this part of the expression over there. So this is the probability of all occurring. But then we want to find out what is the expected value of the tuples that is being returned. And so the expected value of the tuples that is being returned is going to be this probability multiplied by n. And so and so that's why we have this expression over there. Sorry, I should have R here. Did I make a mistake? Is it R here? Okay. Okay. So R should be here as I equals to R. To be exact, then I will be here. Wrong. Yeah, like that. This is correct. So this is going to be the expected number of tuples that is going to be returned. The disjunction, right? It looks very complicated, but it is very difficult to see in this way. So it's a little bit easier if you look at it from this angle. Okay, let's look at the disjunction. Disjunction means theta 1 or theta 2, which is this entire thing. Okay, so if we only consider two attributes right now, right? Let's look at them one by one. Okay, if we have a Venn diagram, and we have this, so we have theta 1 and theta 2. Okay, so what we want to do is let's look at the formula. Let's say this is theta 1, this is theta 2. What is 1 minus theta 1? 1 minus theta 1 is going to be this. Okay. And at the same time, we want to look at what is 1 minus theta 2. 1 minus theta 2 is going to be this. See, include the. Okay, so this one has this line, this one has this line. Okay. So we want to take both of these, multiply together, and 1 minus the 1 minus the how to say 1 minus the resultant of this. So 1 minus the resultant of this multiplication is going to be just 1 minus of this crisscross thing. So we are going to remove away, because it's 1 minus, so we're going to remove away the crisscross, and we're going to end up with just this, which is my disjunction. Okay, I repeat, though, this is theta 1, this is theta 2. If we look at this, 1 minus this is going to be all this. Sorry, did I draw wrong? Okay, 1 minus this is going to be all this line. 1 minus this is going to be all this line. So we are going to, so there's nothing here to multiply it by. So this whole part is going to be, in this case, like 0. So what's going to happen is, if I 1 minus my crisscross line, I'm going to end up with this, which is my disjunction. So this is what the very looks like very complicated formula is actually trying to do. Okay. Okay. And I hope this is clear. And negation is just n minus the size of theta r. And this one we will estimate from the above. Okay, let me know if there's anything I can clarify more on this slide. Let's go. Cartesian product is going to be the multiplication of the size of two tables. So R and S, this is NR, this is NS. So the Cartesian product, actually you multiply both together. Okay, so this one should be clear. Okay. If the attributes of R and S got no overlap, the join of R and S is going to be the same as the Cartesian product of R and S. Okay, so the joint R and S is going to be the Cartesian product of R and S if there are no common tuples there. Okay, so if there is if the overlap of these two is a key, okay, so it means that if R ID, sorry, S ID, and this is maybe I don't put ID here. I put like maybe CID here, but ID happens to be here somewhere. So this is a key, primary key, and ID is a key. Yeah. So there's a in the joint condition, right? there's one attribute that is like there's one common attribute that's a key for R. Okay. Then the rule is that R join S is always less than or equals than the number of tuples in S. Okay, so actually this one is very interesting. It's actually very interesting. Yeah. Did I share this before with you all? Because I scared I forget. I mixed up with last year the class. So hope I never shared before. So let's say this is 1, 2, 3. So this is 1. So this is CS, CS, PHY, chem, chem. So the number of, if I do a join here, right? So this will be joined with this. So the number of tuples, right, is at most equals to the number of tuples over here. Because every single tuple here will join with a primary key over here. Okay, so this definitely, okay, so there are two things you want to think of. If this is a foreign key, if I've set it to be a foreign key, this must be equals to the size of S. Okay, if it's a foreign key, it must be equals to, because yeah, because it must be there, and so every join will have a corresponding entry in my primary key, so it will be there. If it is not a foreign key, so means that I can have funny values here, 5, 6, 7. So all these values will be dropped because they are not in my R table. And so the number of rows that will be returned by this join is going to be less than my number of rows in S. So this is how we can think about it. Okay. So if it is a foreign key, it's going to be equals to the number of rows in S. If it's not a foreign key, it is going to be less than or equals to the number of rows in S. Okay. Right now, and next thing, if R union with S is not a key for both R and S, and so we will have to estimate. So we estimate based on two things. So let's say if the common attribute is A. So let's say if my common attribute is A and R is A. And this is just some random, let's say physics, chem, CS, and this is also physics, chem, CS, so on. Okay, so what we do is we will have to estimate, and we estimate this. By doing this. Okay. In R joined with S, T will produce number of tuples of S divided by the number of unique values of A in S. Okay. And so if we do the join, this will be every single one in R has a chance to join with this number of tuples in S. And so this will be NR multiplied by this. Because every single tuple here has a chance to join with one of the tuples over here. Okay. So this is if R join S. So of course, this is the how to say, the same in both. But if S joins with R, we estimate as is that N S converse the converse divided by B of A of R. Okay, and so we want to take the minimum of this to estimate the size between R joined with S. Yeah, so I will move on to the examples. So in this example, excuse me, in this example, the number of students is 5,000. The number of tuples is 5,000. This is tuples that can fit into one block, and so this is number of blocks. Okay, so I have 5,000 records. One block can fit 50 records. So number of blocks equals to 100. So this is the first table, table student. And then I have ticks, another table of ticks. So number of records in ticks is 10,000, and number of records that can fit into a block for this table is 25. And so the number of blocks will then be 10,000 divided by 25, which is 400. So same theory as what we have over here. And let's say if the number of unique values of ID in my ticks is 2,500, and ID is the primary key of the student. Why is not a key for either student or ticks? Okay, so maybe we ignore this one first. In this example, let's ignore this one first. Let's assume that ID is not the key for either one of these two. So what we will have is I will have the NR times my what's the formula? Can I remember offhand? Can I remember offhand? P of cannot. Sorry. IDS N of S and NS times NR divided by B of ID of R. And the minimum of them. Okay, so we know that this is 5,000 times 10,000, and this is V of S. Let's say this is ticks is 2,500, and the other one will be 5,000 times 10,000 divided by 5,000. Okay, let's assume that V of ID ticks equals to 5,000. So I think this is missing. So not ticks, student. It's 5,000. I think this was missing here. Okay, so this is a little bit funny, but let's take it to be in this manner. Yeah, and so we will have to take the minimum between this and this. So this ID is not the key for either student or ticks. It will be the minimum between this value and this value. Okay. Let's go back to this. If ID is the minimum, is the primary key of students. Okay, let's go back. What's the formula? If ID is the if ID is the key of, so let's where this. If ID is now the primary key of student, so student here, if I do the join between student, join with or ticks. Oh, I know already. Yeah, if ID is not this condition, it will be at most the number of excuse me, the number of rows in my ticks table, which is this. Yeah, sorry. So this is one scenario. If ID is the primary key, it will be less than or equals to 10,000. which is the maximum number of tuples in matrix. If ID is not the primary key, then we have to calculate this formula. Is this slide clear? Okay, I'll go on. The estimation of other operators. So estimation of projection is equals to the number of unique values of V. Yeah, so so number of unique values of V. Aggregation is also equals to the number of unique values, or rather I would say of A on table R. Okay, the size of R left outer join with S. Okay. This is equals to the size of the join between R and S. So this will be based on the previous condition. But if you know the left outer join also includes the columns in R that cannot find a corresponding value in S. And so this will be equals to the size of R joined with S plus the size of R. And this is the upper bound. This is the upper bound. And of course, in the R left, this is the left outer join. Conversely, if we don't have it here, but if we do the right outer join, this will be the size of R joined with S plus the size of S, and we do the outer join, so it will be size of R joined with S plus the size of R plus the size of S. Excuse me. It's not very accurate on this, but these are just excuse me. These are just the upper bounds. Okay, I will not go on to the set operation because yeah, we will avoid set operations in this module. But they are actually very intuitive, yeah. So we can just look through them. Okay, then we have the size of the choice of evaluation plan. So of course we have so yeah, just bear with me for about 3 to 5 minutes. I think we are nearing the end already. So let's try to complete this and then we go for a break. And for those that are not interested in the other part, you can just rest for the evening. Yeah. So yeah. So for cost-based optimization, you want to enumerate all possible ways, but as I said, it is very expensive. So this is the number of different joint operators. So it is really very expensive. So just a very quick one. So R1 join with R2, join with R3, join with R4, join with R5. Right? So altogether, let's say if we use DP, right, 3 joins, right, actually based on this formula, is actually 12 ways now. So if we do calculate this, we will have like R6 join with R4, join with R3. This 5. Yeah. So this becomes one operator then join together. So so in this side, what we can do is this is another 12. So if we don't use DP, right, this is 12 times 12. But if we use DP, this actually becomes 12 plus 12. So it becomes only 24 different permutations to calculate. Yeah. So this is just something extra if you're interested to see this. But actually, it's still very expensive. It's still 2 VOLN times 2 to the power n. It's still very, very, very expensive. So what we do, so these are the various number of combinations that are available. Yeah. So to find the best plan, yeah, this So but we don't need to do this. Yeah. So it's very, very expensive. Okay. So we have these two examples. Okay. R1 joined with R2. So R1, we have A, B, C. R2, we have C, D, E. Sorry, I can't read the question. I need to shift this one somewhere. And primary key is A, C, and E. So assume R1 as 1000 tuples, R2 as 1500, R3 as 7500, 750. What's the efficient strategy for calculating this join? So R1 join with R2. It will be joined based on this key. In this key, it is a primary key for R2. So because it's a primary key for R2, we will take every single row in here will be joined with one row here. So the amount of tuples that will come out will only be at most 1000. Okay, maximum is 1000. If it's not a foreign key, maximum is only 1000. And if we do the resultant join from R1, R2, and join with R3, it will be joining based on this value. So this attribute. So let's say this is R5, right, with A, B, C, D, E. So it will join based on this. This has 1000 tuples. Once again, this is joining based on the a candidate key on a primary key on this, and so at most one value in R5 will be joined with one value in R3, and so the maximum value of this join is going to be 1000 as well. So this is going to be 1000. Okay. Let's see if we join R2 and R3 first. If you join R2 and R3, so let's draw this. R2 and R3 will be joined based on E. This is 1005 and this is 750. And so the best way to join this, not best way, sorry, the number of tuples that we expected will be this, because every row of R2 may be joined with a row in R3, and so this will come out with C, D, E, F of about 1500 tuples. And this will be joined back with R1, which is A, B, C, which is this. C is the primary key over here, and this is 1000 tuples. So this is 1000 tuples. C is the primary key here. So every row in here will be joined with a row here. So this is at most 1000 tuples. So actually, of course, the resultant will be the same. But from here, we can tell that this will probably be the better join order. Just from this simple heuristic, this will probably be the better join order because the intermediate step is going to be less. Okay, I will have a final example. I think this is the final example. This is the final example. Yeah, so it is very similar to what we did earlier. So I have R1. So just bear with me for maybe 6 more minutes. Thank you. With A, B, C, R2 with C, D, E, R3 with E and F. This is how many tuples? 1000, 1005, and this is 750. V of CR1 is 900. V of CR2 is 1100. V of E of R2 is 50. V of E of R3 is 100. Okay, let's look at this this question. The first we want to do is we do R1 join with R2. So because all is not join, so we have to find the minimum value of this join. So based on the formula, right now I can remember the formula. It is NR times NS divided by V of AS, and NS times NR divided by V of AR. And it's the minimum of the two. And so we have 1000. 1000 times 1500 divide by the number. Okay, so we are joining based on the attribute C, and so this will be equals divide by 1100. Right, the minimum of this, and the converse will be times 1000 divided by 900. Okay. Calculating this is going to give me 1364. And then we will do this join with R3. R3 join will be based on R3 is over here, based on this. And so if let's say we join here, this will be this number of tuples here is 750 divided by 100, because the number of unique values in R3 is 100. So if we do it the other way, which is R1 join with R2 and R3, let's try that. Let me see. I can't remove anything, but let's try to change my ink color. Sorry. Okay, let's change my ink color. So R2 join with R3 will be equals to 1500. So we are joining now based on E multiplied by 750 divide by 100 minimum versus 750 times 1500 divided by 50, which is this over here. So I can't remember what the value is. I think I didn't calculate it out here. I think I didn't calculate it out here. Is this the value? I think it's this. Is this the value? I didn't calculate out. Somehow I forgot to calculate out. Okay, let's do this very quickly. So 1500 750 1 and 100, and the other one is 7. So the other one is 50. So equals to this times this divided by this, and this equals to this times this divided by this. So one is 11250, which is this number, and the other one is 25 25 225 or 22,500. Yeah. So this value is equals to this, and the other one is 1,000 joined with this. So with R1 joined with R2 joined with R3 will be 1,000 multiplied with 11250. I need to divide by my 900. Okay, but apparently this join seems to be cheaper than this one, and so this is the better option. Okay, I hope this is clear. And we have come to the end of the syllabus for CS211. Subsequently, after this, we'll be going into Python. So not Python exactly, but we'll be demonstrating how a web server can be created, how we use the web server to connect to a SQL database, how we can serve out an API using the SQL. So I hope to complete that within maybe 30-35 minutes. Yeah, so why I say Python, because the code I'm running off will be based on Python. Yeah, so that's why I say Python. Yeah, so if you're welcome to very welcome to stay. If you have other things to do, you're also welcome to so-called to make your move, and I'll see you on Thursday. But regardless, you are really very honored to be teaching you all for the last 12-13 weeks. So if you are staying, please come back in about let's say 8 minutes time, at about 9:30 already. Yeah. Let's take a break until 9:35. Yeah, just 9:35, and I'll see you in a month's time. Thank you. Oh yeah, please remember to do the surveys. Thank you so much. Yeah. So yeah. Anyway, thank you for staying on. So what we'll do is the following. We'll first give a little bit of context. Why? Because data coming in from the database, you understand, is in a certain format. But data exchange over the internet is typically another format as well. And so what we want to do right now is that we want to understand what is the data exchange format that the internet uses, or rather what is one of the data exchange formats that internet uses. And then at the same time, then after that, we go back into how we can get a web server to extract data from the database and then to return it in this exchange format. And the exchange format that's predominant today is a format called the JSON. So JSON stands for JavaScript object notation, and it is actually, if you are familiar with this concept, but it is a key value pair, very much like a dictionary. So it's really a lot of every single thing that you see on the left is a key, and on the right is a value. So it is simply a long so-called list of key, or rather I would say, cannot say list, but a long dictionary of key value pairs. So that is the predominant exchange format that is used today in exchange of data across the internet. And so you'll notice that, yeah, so I think these are some details that I don't need to talk about. So there are two types of data formats. One is JSON and one is XML. So these two came out, actually when I was doing my PhD, right? These were the two formats that were just emerging. And there was XML, which was a little bit older, and then JSON was kind of the newer version. And over the course of these 10-15 years, right, you have seen that JSON overtake XML. I think I mean, definitely there are people using XML still, but primarily the main exchange format is going to be JSON as preferred. A few reasons. You can tell that the structure of XML is very heavy, whereas if you look at JSON, it's very light. And of course, the lighter one exchange format is like the faster, the less resources you're going to use, and so the faster your data is going to go across the internet. Yeah. So by the way, I'm going to go a bit fast, but if you want me to slow down to explain something in a bit more detail, let me know, and I'll do that. And yeah, so all these we don't need to know today. Yeah. So okay, so this is important. What we are going to do is something called a REST API. I'm sure you have heard of something like that before. So REST API is like it's kind of like a stateless kind of system. Okay. So what do you mean by stateless? Like stateless is where like every time you interact with a certain object, it does not have any memory of what happened before. So an example of a stateless transaction, right, is you going to McDonald's to order a burger. Every single transaction is stateless. So you order today, it's like that. You order tomorrow, also like that. Another person order also like that. So there's no memory that's being involved. Okay. An example of a stateful transaction, right, is you taking the MRT. Why? Because today you take the MRT, now you take the MRT, right? Then you go and take a bus transfer. Then your cost of the transfer is going to factor in your cost of MRT. So that is a stateful transaction, meaning that it actually has some memory of what you were doing before that in order to carry out that current transaction. But REST is a kind of a stateless transaction. And it's actually very important because because of this stateless kind of phenomena, it allowed the internet to grow at a very fast pace because every single transaction is independent. So as long as I optimize the transaction for one part of the entire system, right, I'm able to make to optimize certain portions as and when it is required. So yeah, maybe I'm not expressing in the best possible way, but this is one of the driving factors behind the growth of the internet. Okay, so look, so since we are talking about internet, right? So the question then is, and I used to ask my class in person, how does the internet work? How come you key in a certain text into a web browser, something comes up? How does it happen? Yeah. So in essence, right, what happens is that every time you key in a certain text into the browser, it will go to something called the domain name server. I mean, you guys may know about this, so maybe I'm just repeating some stuff that you know, but I'll just go very fast. It goes to a domain name server to do a reverse lookup of what is the IP address associated with that name server. If it's in the cache, it will return the value from the cache. If it's not, you go to the domain name servers. There are different levels as well. So you'll go up until it is able to find the domain name server that has the reverse IP lookup for the address that you're looking for. then it will give you, rather it will give you back the IP address to go to, and then you will start to go through the routers to look for the IP address. So it goes into various hops. So you hop router by router through ISP, through the through whatever things that you may require, all to the way to the server that that you are trying to access. The server will then return you the data that you require in bytes. The bytes go back to your machine. The machine first takes in the bytes, and then it will understand them to be characters. So characters, then you have that's the first thing, characters, and then after that you recognize your text, which is like your HTML text, your head, your body, all these texts will be recognized. Then you build a tree. They call it a DOM tree. So there's a DOM tree, there's a CSS DOM tree. So from this tree, these two trees, they'll combine together to form a render tree. From the render tree, your browser will then render the elements from this render tree to give you whatever you see on your browser. So those are the basic steps that will be taken when you key in something into a browser. Okay, so this is how the internet works. I'm just very worried that I'm taking a lot of time. So okay, so let's go down. Okay, so I'm done. So the next thing we do is we write a simple web server. Okay. So what is a web server? The web server is one that accepts requests from the internet, or rather from wherever, and then you return a certain so-called response to it. Let me see how we can do this. So I have prepared this already. So if you are on the if you have Python installed and you would like to join in, you can also type along with us to you can try on your own machine. Else you can just look at me, which may be quite boring. So the web server that we will be using is something pretty lightweight. So it is called Flask. It is called Flask. So the first thing we want to do is, of course, naturally, you can see me typing like that, but of course, I'm not memorizing everything. I have the cheat sheet on my second screen, so I'm looking like very like that can type like that, but actually, I'm just referring to the cheat sheet, and that's why I can just type as if I remember every single thing like that. Yeah. So this is the base. This is the base. Okay, so this is the base web server. A Flask web server which first defines an application and then defines the various routes that the web server is able to serve. So this is like the index page, the home page of your web server. And if I do app.run, I'm going to just do a debug equals to true. Yeah. So this would say that if somebody goes to my home page, I'm going to return this text. And as I said earlier, this will be converted to bytes, which will be built into the text in the render tree and then to be shown onto a browser. So here, there will be the header tag, and the text in the header tag is hello world. Okay. So so let's see if I do a Python. So oh, yeah. So now my web server is running. It is running on my they call it the local host, which is my own computer. So my own computer by default has this IP address onto 7.0.0.1. What this 5000 means at the end is it is using the default ports of 5000. So if I were to now go on to, yeah, ta-da. So you have hello world, and I never smoke you, and I will going to show hello world CS211. So I never smoke you. So yeah, so whenever I change, so this is our first web server that we created. Exciting, right? Yeah. So the first time I did it, I also felt very excited. Yeah, and then let's say if I want to have other what's that called? Other links like behind, I can define them here. And then I have define module. We'll do that. Just see random text. Okay. Sorry. So whenever excuse me, whenever I change, the web server restarts itself. Okay. Typically it doesn't happen, but because I have set debug to be true. So if I don't have debug to be true, I'll need to stop and restart the web server again. But because I set debug to be true, every time I do a change, it will automatically stop and restart the web server for me. This is more easier to do debugging. What was the path I used? Oh no, I use modules. Okay. So I can kind of start to define various different paths just like that. So it's quite simple. So far, I mean, it's very intuitive for me to do that. So of course, we serve static web pages is very boring. Very boring to just serve static web pages. So right now, we are going. So we are here already. So we are here. Okay. So what is happening? So we are going to the 5000 default port, and yeah. So create another module. This module works. So I use random text. So debug equals true means every time I change something, my entire web server refreshes. Okay, let's create a simple API. Okay, so let's look at this. So let's say if I want to create a simple API, and we use the following data source. Okay, so what we are doing right now is that we are going to do one step. So in our first example, we created a web server that serves only static pages. Right now, the next thing we're going to do is we are going to create a simple, very simple API, but the data source, right, is in the script itself. So of course, typically we don't do that, but for illustration purposes, that is what we are going to try to do. Okay, let's see if is there a lot of things I need to type. Okay, let's go on here. So let's see. If I'm not wrong, I need to type the following class request JSONify. Okay, there's a whole bunch of text that I need to type, but I'm not going to do that. I'm going to just paste here. So this is going to be the data source. So this data is arranged as a list of dictionary. Okay, this is a list of dictionary. This is one entry in my list. This is another entry in my list. This is another entry in my list. in this entry, there are 3 modules there. In these 3 modules, it shows the instructor, the title, and the module code, the module credits as well. Okay. So what we are going to say that we can do is that we are able to query the module to see what is the module code or the details that emerge from there. Okay, so I'm saying a lot. So I already put in the data source. So right now what we are going to do is we're going to write in the API that is able to return the values there. So let's do let's do a simple one, but it returns every single thing. Okay, so it's like a select star from all like that. Select star from the database like that. So routes. Let's do API modules or and def means define of a new function. So return JSONify module. Okay, so what is happening is that I am taking the modules. The modules what is that? Modules list, and then I'm just saying that if I go to this website, return all the entries in my module list. So let's see what happens if I do that. API. I use module or modules? Module. Let me see. Oh, modules. There's an error. Yeah. So it couldn't recover from that earlier. Yeah. So this is it. Okay. So right now, what I did was that I added this new route, which returned all my modules, and I JSONified. So I converted this to a JSON format, and now when I access the URL, it returns me every single record in my database, in my database, which at this point of time, it is in my actual code file, which is not reasonable. But it shows that this thing is kind of working, but not working as well. But it is like kind of working, kind of working, but not working as well. But let's do this step by step. The next thing that you may want to do is, let's say I want to say that, oh, you return me all the modules is no point. If I have 5,000 modules, then you cannot be returning me all the modules, right? So what we typically do is we want to do a get request. So it can be a get or post request. So for today, we are going to do with a get request. So in the get request, what we will do is the following. So you notice that Python, right, has no curly bracket, and it uses space. I tell you, the first time I did it, right, I thought this is the stupidest thing ever. So sorry, I'm recorded some more. Yeah, I thought this is the funny very strange Why like that? But after I got used to it, then yeah, but I got used to it already So yeah, but first time I did it it's like, why could people use space to like to define yeah. So anyway, this is something in Python. So I don't mean to say stupid but it's like strange strange. Not maybe I should edit that out. Yeah, it's like strange. Yeah. So I think I'm going to offend millions of Python developers. Now I think about it, maybe I should edit that out. Yeah. So, but okay, in context, I'm actually a Python developer. So I have not developed in C for, unfortunately, a very long time, which is why, yeah, I a bit regret, a bit regret. So so anyway, yeah, so let's look at this. So let's say if somebody goes to slash, oh, you see, I forgot that again, slash API slash modules, I will be invoking this function immediately. This function is going to check if I am passing in a certain argument into my URL or not. So if it is, I'm going to do a certain action. If not, I'm going to just return null, okay, or return the error. So I'm going to say if module, how come it's here already? Oh yeah, it's there already. Module code in request dot arguments. So if it is in my arguments, so module, I want to extract out the module code equals to string request dot argument module code. So basically, list string dot arguments is also like a dictionary. So if this key exists in my dictionary, I'm going to extract it out and convert it into a string. Okay. Else, I'm going to return error no module code supplied. Okay. So if there's a module code, I will get the module code. If there's no module code, I'll return that there's error. So if there's a module code, what then do I do? So I'll have to return the individual modules that fit over here. And so I'll first return result and I'm going to use a very slow just a linear scan, which is a O of n algorithm over here. So for each individual module in my modules, which is this entire list on top, if individual module code, if it's equals to the module code, which is here, I will return result dot pen my entire module. Okay. So I'm just going to iterate through my individual modules in my module on top. And if it is there, I'm going to pen it first, and then I'm going to return JSONify of my return result. Oh, sorry, never pay money. So I say, yeah, okay. So let's see. Okay, there's no error here. So the link is API modules. So I have it here. Yeah. So yeah. So right now I managed to sort of reduce the number of like to select exactly what module I want to do. So if I want to do ICT 3102, sorry. Yeah. So this is okay. 3102. If I want to do ICT, what others do I have? 101 is it? No, not 101. 1001. Sorry, 1001. Yeah. So now I'm able to extract out certain modules from my entire dictionary. So this is the third step. So the first step is just the simple web server. The second step is I create a database in my Python script, and I return the entire database. The third step is now I'm able to select a certain record in my dictionary to return out. So the final step that we go through and we end off there is right now, instead of using this, we are going to read from a database, which is the whole purpose of our module CS211. Okay, so okay, so this is if you download the pack, right, that I have on Moodle, this is the database. So this is my SQL database that I exported out. So in my actual program, I actually do one more step to read from a local host database. But I think today we will go up to here and we should be just right at 10:10. So what we are going to do is we are going to edit this one again, and now we're going to import SQL Lite. So we don't need all this anymore. So what we then need to do is let's go to the first one. We cannot have this anymore. Okay, let's remove all this first. So of course, right now, if we if we do this now, what is going to happen? This one, like, oh no, this one. This is API modules one. Sorry. Oh, sorry. Yeah, so there's error because I don't have this modules here anymore. So what I need to do is I need to read from this thing. So read of not this thing, read from the database. 5 minutes equals to SQLite 3.connect. So I first connect to my modules.db, and then cursor equals to connect.cursor. So all I can do this modules equals to cursor.sq. And now this is where the familiar thing comes in, where we are going to select star from modules. And now, ta-da! Very impressive, right? Yeah, but it's actually very simple only, but it looks like, wow, like very impressive like that. But yeah, but it's actually very simple. But this is the reason why we are learning database. Because every single thing that you are seeing on the internet, it is a web service that is accessing some database from somewhere that is doing a very complicated thing of what we are doing today. Okay, let's go to the next one, which is this one. So this part I don't need to change. I need to change from here. So let me go down. I really need this. But right now, this query would probably be different. So select query from queries where module code equals to, and here I need to do some because I'm going to extract a string out, so there's some things that I need to I don't know how to put it. Yeah, some troublesome thing I need to do to just extract out the module code from there. Okay, let's hope that this works. What is it? Yeah. Yes. Okay, let's to show that I never smoke you. Okay. Yeah, you see, got error. So now if I do this extraction, and this is what we have learned in the course, I'm now able to do the return the query out. Okay, so good. I managed to complete everything before 10 minutes past 10. So this is the end of the demo of how we can use a web server to query a database to return the result. The next step then, actually the step number 5 is to use a database to, which is this one, where we actually have the database so-called credentials here, and we connect to a database to get the results from the database. So that will be the one step more lah. Of course, there's still many steps down the road lah. How you can optimize them, how you can the credentials, for example, shouldn't be in the main file, it should be somewhere else. How we can protect all these kind of details. But essentially, this is how a database is being used in real life. So, okay, I've come to the end of the lectures. I'm going to stop recording now.